All right, everyone. This is Environmental Science 20. Hi. Um, Unit 5, Human Health and Environment. Okay. So Chapter 9 is Air Quality and Environmental Health, and this is video number 1. And I recorded the video in class with all my class here, and the video was corrupted when I went to upload it. So here I am doing it again. So this is going to be a little bit of a shorter version. So if you have your notes out, if you don't have your notes out, you can go to my website, which is right here under, okay, so mrmathwell.com, courses, Environmental Science 20. And if you scroll all the way down near to the bottom, because we're getting close to the end of the semester here, Chapter 910, okay? So here's the display, and oh, I guess student notes. Huh. I will have a copy of the student notes right before these two video lessons that you will find on the website. You can copy those down. All right. So here we go. Essential science background. The majority of the Earth's atmosphere, that's about 99%, lies within 30 kilometers of the Earth's surface. So the whole atmosphere of the Earth is about 30 kilometers away from the surface. It's like it just surrounds the Earth like that. And so gravity keeps the gases in there, and so good thing. We need gas to breathe. Wouldn't be good for us to breathe out in bare space there. So there's five sections or regions of the atmosphere based on temperature. So the warmest is the troposphere, about 0 to 15 kilometers up. The stratosphere is next, the mesosphere, the thermosphere, and then the exosphere, and that's up to about 3 kilometers. 3 kilometers up. 30 kilometers? Okay. Yeah, I think that actually should be 3 kilometers. Not 30. 3 kilometers, I think. I have to go back and check that. Hang on. All right, no, it's 30 kilometers. That's correct. So 30 kilometers here. There is a relatively even blend of gases through the atmosphere created by a mixture of air through convection, which is a cyclical movement of air caused by different air densities. Air near land is warmer and less dense than the air above it. The cool, dense air above it sinks, displacing the warmer air below, causing the warm air to rise. So the warmer air kind of spreads out, becomes less dense. The thick, heavy air pushes through that and then sinks, and that's what pushes the hot air up. Yeah. Water that enters the soil and is not absorbed by plants, but filters through spaces in the soil until it reaches rock layer is called groundwater. Groundwater. The porous layer that becomes saturated with groundwater is called an aquifer. Aqua, remember, is kind of a, was that Latin for water? Aqua. Or Greek, Latin, I think. Aquifers are mainly recharged by rain and surface water that come from many kilometers from where the aquifer is located. So rainwater filters through and replenishes the aquifer, okay, or the water underground. So here's a picture that's similar to the one in your textbook, and we're talking about wells that are accessed. If the top of the well that accesses a water table, if the top of that well is somehow underneath the water table level in another area, then that water will naturally flow out. So most wells are not like that, right? The top of the well is far above the groundwater, but in certain cases, if you drill a well into an aquifer and you have like a water table that somehow is formed like this, where the top of the water table is above the well, you have a flowing artesian well. So an artesian well that's flowing is accessed from a point on the ground that is lower than the highest level of the underground aquifer. So again, the picture, I think, explains it well. Here's an artesian well over here, but it's not a flowing one because the top of the well is actually above kind of where the water level would be, right over here. This one is, there's a dip in the ground, but the water level kind of follows the dip in the ground. And so this well right here would be flowing because it accesses this water table that seems to have water piled up a little bit higher on this in this fashion. So a flowing artesian well means that the water will naturally flow out of the well due to gravity. You don't have to pump the water out, and in a lot of wells you have to actually somehow pump the water, bring the water up. But there are some naturally flowing artesian wells. All right. So now we're into section 9.1, where we're talking about that's just some basic information that should be known before we get too far into the chapter. We're talking about air quality and environmental health here now. So what is the difference between a contaminant and a pollutant? A lot of people think they're the same. A contaminant is a substance that occurs in concentrations higher than would be expected. A pollutant is something that has the potential to be harmful. Okay, so if you think about all substances, some of them that are in higher concentrations are contaminants, and the ones that adversely affect living organisms would be pollutants. Pollutants can enter the body of an organism in one of three ways. They can be inhaled. Smoke, dust, and gas can enter the body when breathing. Pollutants can be ingested. That's another word for eaten or taken in through the mouth. And pollutants can be absorbed through the organism's surface layer, such as the skin. So if you touch something, it can migrate through your skin. It can be taken in through the skin or absorbed through your skin. All right, so we're going through this fairly quick. You're just filling in your blanks in your paper there, right? Point source pollutants come from a source that can be easily identified. Examples would be drain pipes, smokestacks from factories, etc. Okay, those are point source pollutants, places where you can actually see. Factories, boats that are leaking, that kind of thing. Non-point source pollutants come from a source that is more difficult to identify and control because the pollutant is quickly scattered. For example, transportation. So if you have a car emitting exhaust, you can't really tell where that's coming from or which car it came from, for example, because the wind blows it around so quick and it dissipates. So transportation emissions are an example of this. Also, runoff from farms or from from roads, even runoff from cities, off the streets, off people's lawns, and that it goes and it dissipates right away. Tough to tell where it comes from, but yet it is still pollution. It's called non-point pollution. Natural sources of air pollutants include gases from volcanoes, gases given off by decaying plants, and gases expelled from animals by way of belches and flatulence. So those are natural air pollutants that we deal with all the time. Pollutants that are a result of human activity are called anthropogenic. So anthropology is like the study of human civilizations, human activity. So human activity, genic is Genesis, the start of, the beginning of, to begin. So it's human origin. Okay. Primary air pollutants are substances released directly into the atmosphere in amounts that pose a health threat. And from factories, from volcanoes, from fires, from exhausts, those are primary pollutants. Secondary air pollutants are substances that result from primary air pollutants interacting with one another and with other substances, including sunlight, which smog is a familiar example of a secondary pollutant because, as we'll learn more in a few minutes, smog is the combination of different gases in the presence of this radiating sunlight that causes this smog. So acid rain is another one, the generation of ozone through smog and exhaust fumes and stuff like that. These are secondary pollutants. They come from primary pollutants and chemical reactions. They are further pollutants. Okay, primary, secondary. A yellow-brown haze above or near densely populated areas is called smog, or technically photochemical smog. This forms when pollutants from exhaust pipes of cars and trucks and smokestacks of industrial plants react chemically in the presence of sunlight. This reaction takes place up to about 1 kilometer above the ground, as you see in the picture right here. Maybe a kilometer up the ground, off the ground here is maybe this surface. The interface there between like the smog that you see in the picture and maybe clear blue sky up there. One of the main components that forms this reaction is ozone, is ground level ozone. This can irritate the eyes, nose, throat, and lungs of people and animals. This ozone that we would be breathing in smog is different than the ozone layer. The ozone layer is a layer of ozone, same chemical, same elemental form of oxygen, but it's way up in the thermosphere or the ionosphere. That's where the ozone layer should be, and that protects us from UV radiation. So if there's ozone that we breathe in because of smog, that's not good. Okay, the chemical formula for ozone is O3, and that's a subscript of 3 there, O3. Okay, so ozone layer, good, way up high, deflecting and absorbing and UV radiation, that sort of thing. ozone that's produced by car exhaust down where we live, not good. Yeah. All right, sources and effects of some primary air pollutants. Burning fossil fuels generates carbon monoxide and nitrogen dioxide. Also, volcanoes burning plant material can cause and create particulate matter, PM, particulate matter, which are very tiny solid particles suspended in the air. Also, burning sulfur-rich coal and other biomass produces sulfur dioxide in the air. Paints, glues, fabrics, building materials, personal care products can produce something called volatile organic compounds, or in short form VOCs, which can cause eyes, nose, and throat irritation, and in higher concentrations damage internal organs. VOCs. So that fresh paint smell, right when you paint, right? Not good. It's actually not good. You're actually sniffing in some of those chemicals that are coming off of the paint. Even, I was thinking about this, like new car smell. Like, I love new car smell, but probably not good. You're just sniffing plastic or whatever it is. Yeah, I don't know. But so you can read up on VOCs, not good for you. And they're in everything, like furniture, clothing, cookware, exhaust vents, lights even, electronics, right? Carpets. So we're going to make a particulate collector. So basically what a particulate collector is going to be is a sheet of paper with some string, and we're going to have two big strips of packing tape with holes, two big holes, one sticky side out and one sticky side in, and so that it floats around. We're going to hang it in the hallway, we're going to hang it in the shop, bathrooms, science lab. We're going to hang this for a couple weeks and see what kind of dust particles and particulate matter might be floating around in our air, and we'll take them down, examine them. Maybe we'll do some comparison. Talked with the class, and they figured that the shop would be the worst. Yeah, with dust from cutting wood and stuff. I think so. Figured the boys' bathroom would be next. I don't know. The science lab, it'd be interesting to see what is floating in the air in the science lab. Anything we can, and the gym, like gym hallway, or you never know, that could be. You never know. So we'll see. We'll see which one's worse. I don't know. What do you think? Which one's going to be the worst? Probably grade 9 hallway. Ugh, grade 9, say. Moving on. Indoor air pollution. Oh, secondhand smoke. Bad stuff. Secondhand smoke contains over 4,000 chemicals, if you can believe it. Many of these are toxic, including carbon monoxide, formaldehyde, ammonia, and arsenic. These gases have been known to cause cancer. Way back in the day, back in the 20s, 30s, 40s, it was really cool to smoke cigarettes, and no one figured they were that bad. But now we know that they cause cancer and all this garbage. And even secondhand smoke, man, if you inhale that, it's almost like you're smoking it yourself. It's a pretty big deal. So a lot of places have gone to no smoking sections indoors. You have to smoke only outdoors, which I think is probably pretty safe. Pretty good idea, knowing what we know now. VOCs, as we mentioned before, those volatile organic compounds such as formaldehyde and acetone and benzene are in many synthetic household items such as furniture, carpets, adhesives, cleaning products, and paints. PVC pipes also emit VOCs. So yeah, the more you learn about this stuff, the more you realize that everything around you is emitting chemicals because of their production, or because of the lacquer or the protective barrier that's on the outside of them. But there's a lot of chemicals that are kind of floating around in the air that we don't really know about so much. Yeah, be careful. So radon is a natural indoor pollutant. The element uranium is sometimes found underground in rocks and soil. This element breaks down over time and releases radon gas, which can collect in homes or buildings above the deposits. People exposed to higher amounts of radon have developed cancer as a result. Radon is number 86 on the periodic table of elements. And even though it's a noble gas, it's rather inert, it doesn't react much, still not good if we're breathing it in. So uranium breaks down to radium, which breaks down to radon, and that in the surface area can collect with buildings over top of the rock in the soil that radon would normally sort of emit and go out into the atmosphere naturally kind of gets collected, like in your basement or in your house. So that's one of the things that indoor air quality companies test for, usually radon. And yeah, something you should consider doing, seeing what your home is like and see if it's radon free. Okay, asbestos is a material that's used for fireproofing and building insulation, and it was used very heavily all over the world. It was just like the next best thing to sliced bread. It was so awesome, cheap, and really usable and useful and easy to manage. But we found out that when you inhale this stuff, it sits in your lungs. It doesn't break down, and it can cause cancer and really mess up your lungs. And we're going to watch a video soon about this and talk about the effects of it. But asbestos is not generally used today. But in older buildings, maybe older than 20 or 30 years old, a lot of buildings have asbestos in the walls and the ceiling. And it's not a bad thing if it's in there and undisturbed. It's when it becomes airborne and you breathe it in, it's a problem. So with a lot of these old buildings, if they have to do any major renovations or that, it's like, probably going to just carefully tear it down and build a new one that doesn't have all this nasty stuff in it. But for a lot of old buildings that are being used today, it's, they have their air purifiers and stuff. So as long as you don't blow a hole through a wall that's lined with asbestos, you're probably fine. So undisturbed, relatively harmless, but yeah, that's a blow-up picture here of asbestos. And you imagine these little particles getting in your lungs and never leaving, causing a problem. So I think I have, so I have a video on my website. You can please watch that. It goes through a story